Hello dear students, here we are into extractions of metals, and we have seen aluminum as a different metal, a different way it is extracted, different way it is concentrated. Concentration you have seen in the previous video. So after concentration we get the alumina here, we have alumina over here. Now this alumina is from here, this alumina is reduced by electrolytic reduction, we call it. Electricity we use. All right, now let us try to see. You know, in electricity there are two terminals, positive terminal and negative terminal. The positive terminal over here, this is graphite anode we call it, and the negative terminal we call cathode. And as we know, by nature metals lose electrons, so they form positive ions. So the positive ions will go and get deposited at the negative terminal. So metals form cations, and cations go and get deposited at the cathode. So let us try to see what has happened. Molten alumina. Now alumina has a melting point over 2000 degrees centigrade. So it is very costly if we use alumina only and to melt it. It will be costly, so we add cryolite. Cryolite is Na3Al(F6), and we use CaF2, feldspar. So CaF2 will further reduce the melting point of the mixture, and alumina also, cryolite also has got less melting point. So combining the effect of these two, aluminum oxide melting point is reduced to almost 1000 degrees centigrade, and the whole thing melts, the whole mixture melts. And also the feldspar is itself ionic. This is ionic, so adding these two means that the mobility of the ions increases. So ultimately what has happened, let us have a look. We have taken alumina, this is Al2O3, that is my main ore. In a time I have mixed it with cryolite, that is Na3Al(F6), and little bit of feldspar. Now these two, again I told you, lowering down the melting point of the mixture they are used, and secondly to enhance the mobility of the ions. Now what happens, children, when electricity is supplied, then aluminum oxide will break. It's a complex reaction, but we will see symbolically what happens. Aluminum plus, so this is how we get like this. So aluminum firstly dissociates. Now the alumina dissociates. Now aluminum goes to cathode. At cathode, what happens? At cathode, what happens? We will have what to say, Al plus 3 electrons, and aluminum will get deposited. So this blue thing is aluminum layer. Alright, so molten aluminum comes down. Now oxygen at anode, what will happen? Have a look. A complex reaction takes place. Anode, firstly let me put, I can double it, so 6 electrons let us take. Then what happens? It will form 3O2, and it will release 6 to the 12 electrons. So oxygen will be formed. 12 electrons will be reduced, and oxygen will be formed at the anode here. Now oxygen is a gas, it's going up, but since there is heat over there, it will react with the graphite, which is carbon, and it will form carbon dioxide. So carbon dioxide will be formed. So gradually the anode is eaten up, so time to time it has to be replaced. So carbon dioxide is formed. Also we also put some carbon lining on the top, because it's a very it's a very hot electrolytic chamber, and therefore in this as soon as oxygen is going up, say by chance if it will come in contact with air, everything will catch fire. So we line up on the top with carbon, so that oxygen will form carbon dioxide first without burning the whole entire electrolytic vessel. And this is how electrolysis, electrolytic reduction, that is removal of oxygen. So the summed up reaction will be 4Al plus 3O2. So now from here we keep on taking out the aluminum and we form brick. So here there is an outlet, time to time it is open. Also understand, aluminum, freshly prepared aluminum is a bluish white metal. But as soon as it is prepared, it reacts with oxygen in the air and forms a passive layer on itself, on its surface, and hence it turns to be grayish white. This is aluminum framing, so grayish white. Thank you.